Hi guys, today we're going to be talking again about exponents, but this time we're going to be introducing what is called the power of a product rule. So let's go ahead, jump in, and work on an example to showcase what this rule looks like. We have 6n to the second power, and we know that anytime we're taking an exponent, we are multiplying the base by itself that many times. So I want to rewrite this as 6n times 6n. We got once, we got twice, because we're taking it to the second power. And remember, whenever we have a coefficient sitting right next to a variable, all that means is that it's multiplication. There's an invisible multiplication sign sitting in between our coefficient and our variable. And because this is multiplication, it doesn't matter what order we write these things in. So I'm going to go ahead and move these things around so that like terms are sitting next to each other. So we have 6 times n times n. Okay? Now, again, because multiplication, I'm just going to go ahead and multiply these things together. 6 times 6 is 36, and n times n is n to the second power. Now, thinking back to our power of a power rule, when we had a base inside of parentheses and that exponent sitting outside, we were able to multiply whatever exponent was sitting inside by the exponent sitting outside. Now, thinking back to what exponent would be sitting next to our variable, we know that this is n to the first power because one single n exists. We also know that this 6 has an invisible to the first power that we just don't write out because there's a single 6 written there. We don't need to write the exponent, we just know it's there. Now, if you guys notice, 36 is how we get, or is 6 to the second power. So this rule is very similar to the power of a power rule in that we're going to be multiplying the exponent from inside the base by what is outside the base. I'm going to go ahead and erase this. Make sure that this example is in your notebooks, but let's go ahead and create a rule for what this might look like. Oops, wrong color. We have something sitting inside of the parentheses. I'm going to make this variable x, and we have another variable, y, and then we have a exponent sitting outside. Whenever we have two things or more inside of our parentheses, we can always rewrite this. We can always rewrite this as x to the nth power times y to the nth power, okay? Let's go ahead and do one more example together. I'm going to keep this rule up there. Let's talk about 2y to the fourth power. Now, again, we know that there's an invisible 1 sitting right there, and there's an invisible exponent of 1 sitting right there. So right off the top of our heads, we should know that this is 2 to the fourth power times y to the fourth power. So let's go ahead and prove this to ourselves. Because we're taking 2y to the fourth power, that means I need to write it out 4 times. 2y times 2y times 2y times 2y. I'm going to go ahead and rearrange that so the like terms are near one another. 2 times 2 times 2 times 2 times y times y times y times y. So if we expand out 2y to the fourth power, we end up with this long guy right here. Now, the final thing that you would just need to do is solve what 2 to the fourth power is. So let's go ahead and do that very quickly. One way that I like to do this is I like to make it almost like a tree where I'm just going to take each piece of the puzzle and combine it as I go. So I know that 2 times 2 is 4, Let's bring down this next 2. 4 times 2 is 8. And then I'm going to bring down that final 2. Times 2 is 16. So I know, finally, that 2y to the 4th power is the same thing as 16y to the 4th. Go ahead, box that answer off. Make sure that this rule up here is written very clearly in your notebooks. Like I said before, it's really important that these are crystal clear. Maybe you want to highlight them. Maybe you want to box it off. Just make it very, very apparent in your notes, okay? I hope you guys have a great night. I'll see you tomorrow.